Hello all, if you are following our channel means you may know that this is the continuation of the previous video. So in the previous video we were doing CNN multi-class, that is 10 class classification with Paddy crop or disease classification. So in that video itself I have said that our accuracy will achieve more than 90. So here you can see our accuracy is 95 and loss is also decreasing. When compared to mini batch loss, the validation loss is less. So we have also set to decrease the base learning rate. So for every approaches, for so the learning rate is also decreasing. So then we can just see the plot which we have obtained. So this the previously we saw, this is the 10 classes of uh, paddy disease, and this is the normal paddy, so others are the diseased paddy. So this is the first graph we have updated. So this is the next training progress graph which we are obtained. So in the fifth iteration we are getting and validation accuracy of 95.56%. So and time you can notice that it is 8 minutes 17 seconds. So the approaches we are using 5 and the iterations per approaches is 35. Maximum number of iterations is 95. So this is the difference between the training and the validation. Training is in a blue graph and the validation is in red. And the training which once it is ongoing, this we will display this somewhat light blue color. The process whether it is ongoing, we can see here, you can see some light blue colors. So this is the difference between the accuracy. So also loss also the same, but it's in red color. So you can notice that from the graph that as the accuracy increases, the losses decreases, so that you can just know that our method is producing better accuracy, while we are using some not using the predefined ReLU function, and we are just using the predefined ReLU function. Based on that, we are getting some improved accuracy more than 90, that is 95% we have got. So then we can just check the other this also previously I have said that we have used nearly 15 layers. Those layers and from which layer the output is going to which layer, and finally what is the output that is given over here. And this is the description of the activations of that layer, in which layer what is it's going on, what is its name, what are the learnable parameters in that layer. You can just see by using the network analyzer. Then we have just made to display the confusion matrix plot also. So here you can see the confusion matrix plot also here. So this is the confusion matrix graph we are obtained for this work. And finally this is the ROC curve. So this is our input CNN. So here the x-axis as ROC curve, x-axis we will get as false positive, and in the y-axis it's the reduction rate. And then you can just see the other variables. This variables also we have used some other uh, pre, code which we have defined to display the code, and that variables we have see over here, that is accuracy, sensitivity, specificity and all. So you can just see in this thing in the variable plot. So these are the variables which we have got. This is the confusion matrix graph we obtained for this. And then the accuracy for every 10 classes, and then the sensitivity for 10 classes, then specificity for 10 classes, precision, precision recall, F1 score. And also they have just mentioned what is the group categories. 10 classes we have made, no. So what are the classes that is the order of classes also just displayed. So this is the code for CNN without using the ReLU normal default ReLU function, and using the improved ReLU, that is the predefined ReLU, by using and class definition. So this is the code for that. So in the next video, we will just upload that this thing which we have saved over here, net transform. This net transform we will be using in a guy function to just test it. So by using this, now we have trained our function. So while now itself we saw it is for 5 approaches itself, it is taking nearly 8 minutes. So if you are running every time once, it will be causing some time issues for that. So in the next video, we can, to save our time, we are just saving this variable in over here, and then we can call it from some guy function to test each and every time. If you want to test an image from a particular class, means you have to call that, say, image which you need to test in that guy function. So in that way we have made a guy code, and it will be shown in the next video. Thank you.